Hello, geometry students. I am super happy to be teaching you another lesson in geometry. I can't wait till the day that we can actually learn together in person. Hopefully that will be soon. We have finished up section 5.1. So today we're going to be doing lesson 5.2. Now, something that might be helpful for you to have when we are going through this lesson is two documents that should be in your chapter 5 materials under chapter 5 lessons. One of them says word bank for chapter 5 proofs, and the other says 5 steps to setting up a proof. If you don't have those yet and would like to have them with you while you're doing the notes, you could pause the notes now and go find those. You don't have to have them, but it just might be something that might make things flow a little bit better for you. So again, hopefully you're watching this YouTube video on your phone so that you can zoom in on the board as needed during the lesson. And we'll just go ahead and get started. So this is going to be lesson 5.2, and the topic is congruent polygons. Congruent polygons. Now, the only thing that you need to worry about writing on your notes is what I put on the board. If I say something out loud but I don't write it down, you don't need to put it on your notes because I'm trying to minimize the amount of writing for you in these notes. So, congruent polygons, do you know what that might mean? They are two shapes that are basically identical. So the official math way of saying it is two polygons are congruent if and only if all corresponding angles and all corresponding sides are congruent. So it has to be the same shape and the same angles, like two rectangles that have exactly the same lengths and they all have 90-degree angles. All right, let's look at a few theorems here that we're going to need to know in order to talk about congruent polygons. So the first theorem is called the third angle theorem. Third angle theorem. So what that theorem says, I'm going to say the words now, and all you have to do is write the picture, that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are congruent. So let's draw a picture here. Let's draw two triangles that are congruent. Well, they're going to be congruent. And we have one triangle has an angle of 60 and an angle of 80, and the other triangle has an angle of 60 and an angle of 80. Now, the way that we show that angles are congruent in a picture, oftentimes in a textbook it is done in pink or red, it doesn't have to be, is you see where these two 60-degree angles are the same, we can put one arc on those angles, and then because these two angles are the same here, we can put two arcs there. That's a way of showing those two angles are congruent. Now, can you think, why would it need to be the case that the third angles would also be congruent? This has to do with something we learned in the last lesson. Since both angles have to add up to 180 degrees, if these two angles here, 80 plus 60, add up to 140, the third angle has to be 40 degrees. Well, the same thing would happen in the other triangle. So anytime you have two triangles where two of the angles are congruent, the third one must be also. Now we have 4 more kind of rules or theorems to talk about here. The next property that we're going to talk about is the reflexive property. The reflexive property of triangle congruence. Now, this is something really that just usually only briefly comes up in a geometry year, but the word reflexive property is something that's going to come up a lot in this chapter, not necessarily in this particular context, but this is a good time to bring it up to you. So the reflexive property of triangle congruence tells us that triangle ABC is congruent to triangle ABC. I know that sounds completely obvious, but we can sometimes use this when we're making proofs as part of a larger step of statements that we're making. So any triangle is congruent to itself. That kind of does make sense. Now, the symmetric property, again, these three properties are not going to come up a lot the rest of the year, but the words will. The symmetric property of triangles we won't necessarily say, but we might say symmetric property of a segment. So symmetric property of triangle congruence says that if triangle ABC is congruent to triangle EFG, then, and then you basically just flip the order here, triangle EFG is congruent to triangle ABC. There's a lot of letters here, and I know it's a pain to write all that down, but basically you can flip the order of the triangles and it doesn't matter. Now you're not changing the order inside the triangle description. Like you're not changing the order of E, F, and G, but you're just flipping the order in which the triangles themselves appear in your statement. Okay, and then we've got the transitive property. The transitive property of triangle congruence. So the transitive property of triangle congruence is a rather long statement. It starts off with if triangle ABC is congruent to triangle EFG and triangle EFG is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. Now that is a lot of writing, but I want you to see how we're kind of skipping a step here. It says ABC is congruent to EFG, so that links these two triangles, and EFG is congruent to JKL. Do you notice how ABC, triangle ABC and triangle JKL are both congruent to EFG? So since they're congruent to the same thing, they have to also be congruent to each other. And that's the basis for how we know the transitive property is true. There's one more theorem, and I'm sorry for all the vocab, but this is essential material for you to understand. Like I said, the main thing here is to understand the context of reflexive. Reflexive means that any shape is congruent to itself. Symmetric means the order in which you list those shapes doesn't matter. And the transitive property, in essence, tells us if two shapes are congruent to a third, then they are congruent to each other. This is just kind of the fancy math way of saying it. Now, there's one last theorem before we do our examples. This is called the corresponding parts of congruent triangles. That is a big mouthful. Let's keep going. Are congruent. Now, that is a lot to say. The corresponding parts of congruent triangles are congruent. We have an abbreviation for that. It is capital C, like corresponding, capital P, like parts, capital C, like congruent, capital T, like triangle, and then capital C again for congruent. So the corresponding parts of congruent triangles are congruent. C, P, C, T, C. So the words that go with that is that two polygons are congruent if and only if the corresponding parts of congruent triangles are congruent. So what that's basically telling us is if all the corresponding parts of two triangles are congruent, then the triangles themselves are congruent as well. Okay, so what I'd like to do now is have you go to a new page, or maybe down at the bottom of your page. We're done with the vocabulary. Now what I want to do is do some examples that make this a little bit easier to process, because it's a lot of information. So, let's go ahead and do example 1. Example 1 is going to tell us to complete a congruence statement. To complete a congruence statement. So let's draw an example here of two triangles, and we are looking at their angles. And then we're also looking at their sides. So we have two triangles in this picture. We can see that they have 3 pairs of corresponding sides that are congruent with 1, 2, and 3 hash marks. And then they have 3 pairs of corresponding angles that are congruent. So all 6 parts are congruent to themselves. Because of that, and let's put some letters on here, H, G, T, and K. So I'm going to start off this congruent statement. Triangle GHK is congruent to triangle blank. Now I'd like you to look in, zoom in on your notes, and see if you can figure out what order you might want to put the letters in for this other triangle. The order does matter. So, we need corresponding parts to compare to corresponding parts. So for example, whatever letter I list first here needs to correspond to the angle that's listed first here. So we need to ask ourselves, what angle is congruent to G? Well, if we look in this triangle on the left, this angle with a G next to it is congruent to the other one with a G next to it. So we're going to put a capital G here first as well. Now, what angle corresponds to H? If we look at the triangle on the left, where the H is, there's 1 arc in it. What would be the angle on the right that has 1 arc in it on that triangle? It would be T. And then K corresponds to K. So you can also kind of look at it going directionally. Going from G to H to K is the same as going from G to T to K. So we're going along the sides of the triangle in the same order. Okay, so that's called a congruence statement when we say that 2 triangles are congruent to each other, and the order of the letter matters because from this information I actually know 6 things. Because G is first here and here, I know that angle G is congruent to angle G. Because H and T are second, I know that angle H is congruent to angle T. And that because K is the 3rd letter in both, I know that angle K is congruent to angle K. I also know about the sides. Do you see how G and H are the first 2 letters here? And T, G and T are the first 2 letters there? So that's how I know that GH, this side right here, is congruent to GT, this side right here. So GH is congruent to GT. I can also do the same thing with the 2nd and 3rd letters. H and K are the 2nd and 3rd letters here, and T and K are the 2nd and 3rd letters there. So I also know that HK is congruent to TK. And then the final set of information would be to look at the 1st and 3rd letters. So maybe G and K here, and G and K there. So GK is congruent to GK. Now this is an example, obviously, of the reflexive property, this last statement here, that GK is congruent to GK. Do you see how it's the same exact segment? We also know that's true by the reflexive property. Okay, you guys have done a fantastic job. Let me take a look at the notes on the back. I think I just want to do one other example with you, and then the rest we'll go over in our homework. So I would like us to do our first proof together. And this is the spot where if you have those 2 documents I mentioned earlier, it might help you. The first document is called the Word Bank for all the Chapter 5 proofs. And the second document is called 5 Steps to Setting Up a 2-Column Proof. So we're going to use those in doing our proof. So this is going to be example number 2. and it will be the last example in the notes. And I'm going to draw a picture, and it might be helpful if you could copy it down. Those triangles should be looking like they're the same size. Now, anytime we do what's called a proof, there's going to be something called your given. That means the information you're given to start the problem with. The given for this, and let's label the angles here, L, M, N, P, and O. The given is that angle L is congruent to angle P. So I'm going to take my marker and put an arc on L and P. And then it also says that segment LM, so LM, is congruent to segment PO. So let's mark that. LM is congruent to PO. Good. Another piece of information we have is that LN is congruent to PN. Okay, I'm going to mark that up. LN is congruent to PN. By the way, it doesn't matter how many hash marks I use, as long as if LN is congruent to PN, it has to have the same number. So they both have one hash mark on them. And then the last piece of information, I'm running out of room, so I'll put it over here, is that MN is congruent to ON. MN is congruent to ON. So this segment here is congruent to that segment there. Now I have not drawn this figure perfectly. If you were using my notes that I normally print out to hand to you, the diagram would be given to you, but it's been labeled correctly. It's just I haven't drawn it exactly to scale. Now, those of you that have your document titled 5 Steps to Setting Up a 2-Column Proof, go ahead and read what it says for statement 1. The first thing you do when you're writing a 2-column proof is you draw a lowercase t. So you draw a big T on your paper, the letter T. That says the information next to step 1. Step 2, what does it say for step 2 under 5 steps to setting up a 2-column proof? Step 2 is to label the left column statements. So we put the word statements up here. And then the right column, reasons. That's step 2 for writing the proof. All right, go ahead and read what it says next to step 3 on 5 steps to setting up a proof. Next to step 3, it says, next to statement 1, write whatever statements you have been given. So, we have been given all of this information. Angle L is congruent to angle P. We're just copying this down. Segment MN is congruent to segment ON. Segment LM is congruent to segment PO. And LN is congruent to PN. So we just copied literally all the information that we have been given right here. We just literally had to just copy it down into that spot right there. So that was what it said next to step 3. It also said next to reason 1, write the word given. So our first reason is given. So essentially, we're writing down the information we've been given, and we're writing the word given next to it. Now, the next step, step 4, go ahead and take a second to read that. It says, for your last statement, write whatever you're trying to prove. If you don't know how many steps you'll be making, use the number 10. You can always change that number later if you end up making more statements. So we're going to put a number 10 down at the bottom here, and we're going to put what we're trying to prove. Now again, if I was doing this with you in notes, I would have they would all be printed up for you. but in the information where you were given this original problem, it said prove that triangle LMN is congruent to triangle PON. So this was information you would have been given at the beginning of the problem. Whatever it says next to the word prove, we copy down for our last statement. So triangle LMN is congruent to triangle PON. This is what we've been given. This is what we're trying to prove. We don't know how many statements we're going to need to make, so we're just putting the number 10 there, and then we can always change it later. Now, for step 5, it says, draw and or label your diagram and try to determine what missing information you still need to include in your proof. Check the word bank for chapter 5 proofs to get some ideas. So let's go ahead and think about what's going on here. If I want to prove that these two triangles are congruent, I need to show that all 3 angles are congruent and all 3 pairs of corresponding sides are congruent. We already have 3 pairs of sides taken care of. This side is the first pair, these 2 sides are the second pair, and these 2 are the third pair. So we already have 3 pairs of corresponding sides that are congruent. We need 3 pairs of corresponding angles also. All 6 parts need to match up. Well, we do have 1 set of angles here, but 2 are missing. So this is where we're going to tie in stuff that we have been learning up until now. So if we go ahead and look at this triangle right here, can somebody tell me why it would be that these 2 angles are congruent? This is something we learned in chapter 1, and I remember telling you we were going to use it hundreds of times this year. Why is it that angle LMN would be congruent to triangle PNO? Why would they be congruent? Okay. The reason is because of vertical angles. So what we're going to write for statement 2 is angle LNM is congruent to angle PNO. And the reason is, statement 2, vertical angles are congruent. Vertical angles are congruent. So we just made a statement that we know to be true, and we just explained how we know it to be true. All right, now, remember I said I needed 6 pairs of corresponding parts that were congruent? I had all 3 sides and 1 pair of angles. I just got a second pair of angles. How is it that I know the third part are congruent? The hint for that is it's something from today's lesson. I'm going to write down that, and let's put a mark up here. I'm going to write down that angle M is congruent to angle O. See if you can figure out why. This is step 3. Angle M is congruent to angle O. Anyone have the reason? You can look in your word bank for chapter 5 if you would like. The reason is the third angle theorem. Third angle theorem. Okay, now here's the cool thing. We can erase the number 10 that we have here and put a number 4 here instead, because we're done. We've proved that we have 6 pairs of corresponding parts that are congruent. So the shortcut way of saying that the 2 triangles are congruent, our reason is because corresponding parts of congruent triangles are congruent. Once we have all 6 pairs of corresponding parts congruent, we are allowed to say that the 2 triangles are congruent. So you guys have just finished your first proof. It's a lot of information to digest. I'm super proud of you for listening to the notes, and I look forward to seeing you in Zoom. Bye.